Hi everyone, welcome back. This is the second tutorial about Matplotlib. In this tutorial, we are going to learn about subplots. So the outcome of this tutorial will be an image like this one, 3 by 1, 3 column and 1 row. So 3 smaller image inside one image. And then also a figure like this where we have 3 by 3 image. It means that we have nice smaller image inside one big image at the end. And yeah, so first thing we need to do is to import the library. We import matplotlib.pyplot as plt, and we also use numpy package for this tutorial. We use this command to specify the font of the image. For instance, the number here or the letter inside the figure. And similarly, with the previous tutorial, here I have X array, which is equal interval by using numpy.linspace. And then I have y1 as side function, y2 as cosine function, and y3 as combination of sine and cosine function. However, the frequency is twice higher. So in here I have number of column is 3 and number of row is 1, which is stand for we only have one row for this image and 3 figure as 3 columns. And in order to generate the figure like this, we use the command figure axis. So the short name is FIG and the axis is AX. We can put whatever letter that we want. However, usually people use fix and AX and equal plt subplots. So first argument we put the number of rows, and second argument we put the number of columns, and we can also pick the figure size. So 10 is stand for the width and 4 is stand for the height. So because we have 3 columns, so we can specify the axis. So from the first column, the first figure corresponding to the number 0, as you can see in here. So for each first figure as 0, second figure as 1, and third figure as 2. So we will specify the information of the plot. We will specify the information for each figure by using the index, as you can see in the square brackets here. And we use the command dot plot x and y1. So that is the side function. That's why it's go across the location 0 and 0 and the center point. And then we use similarly in when the axis 1, we plot the cosine function, and as you can see in the middle figure here. And then we plot the y3, which is a combination of sine and cosine, and because it has higher frequency, so that we see the signal is closer to each other, the wave closer than in the previous two image. So this way of specify and put the information inside specific panel, it seems a little bit repeated, and in order to do it like faster and more concise, we use the for loop, as you can see here. So the data is similar. We have x, y1, y2, and y3. However, here we have a for loop to iterate from the panel number 1 to the panel number 3. So the way we did it, we loop through the column because the row equal 1, so that we put the number of column here, which is 3. And we also need to make a list of color, because we need to specify the color for each line in here. So that's why here we have a color, And before that, we have x as first argument. Here is the x value, and y underscore is a list of y1, y2, and y3. So at the first loop, it will take y1 and plot in the panel on the right leftmost figure, and in the second loop, it will plot the figure in the middle figure, and as the last loop, when I equal to, then it will plot the rightmost figure, and the color will corresponding to M magenta color, as you can see in here. So this way is a little bit compact, and the code is more clear and clean than in the previous one, where we specify uh, as you can see, we need 3 lines for each panel. However, by using for loop, we can reduce from 9 lines to only 3 lines. Okay, the next section is about making a lot of subplots. For instance, we need to have 5 smaller figures inside one figure. So we make 9 different panels. And the way we did it is also similar. We also use for loop. So our first thing we need to taking care of is that we have 3 by 3 matrix, which is stand for so the number of column. So the first row will start with the index 0, second row will be with the index 1, and the third row will be with the index 2. So we will look in the row first. So for I in the range of number of rows, then we will look in for j in a range of columns, which is mean that when we at the row I, for instance, row number 0, then we will look through the next 3 columns, and then when we go to the row number 1, it will look through the column at row number 1, as you can see in the portal here. So, and then similarly for the last row, and inside the loop here, it's just a function to remove the tick and the label of the figure. It's not very important here, and I put the command .text, as you can see here, to show the text in here. Yellow stand for the first I index and also the J. So and the last panel 2 by 2, which is stand for the last row and the last column. Just keep in mind that in Python the first index starts from 0. So even you have 3 here, but it will go from 0, 1, 2. You can practice this at home by modifying the number 3 here by 2 or whatever number you like. Can see the output, how does it look like, and learn from it. So in this image, we have 9 smaller panels inside one bigger image. However, it has a similar size, so we can also make a new, for instance, for panels inside one complete image with different panel size like this one. So even though it looks a little bit complicated, but in this very easy. So we can also use the command plt.subplots to grid. So in here, the first argument inside the brackets is 2 and 3. 2 stand for 2 rows, 3 stand for 3 columns. So for the first figure, AX0, as you can see in here, so this section of the code is just to print the text, as you can see in the middle of each panel, and the number, the second argument in this command line 0, comma 0, it's just for the first row and the first column. And then we go to the AX1, as you can see here. So we have the second argument is 0, 1, which is stand for the row 0 and the column 1. And we go to the AX2. AX2 is here. So similarly, the first argument is keep the same as in this figure, because we only have 2 rows and 3 columns. And then here we have number 1 and 0. Number 1 stands for row number 1, and 0 stands for column 0, so the first column. However, here I specify column span 2. It means that it will span from column 0 to column 1. So that's why it have a pattern like this one. And then in the final panel AX3, we have similarly as before, 2 and 3 keep constant, keep the same, and then we have 0 and 2. So 0 is which means that the row is 0, and then we span the row, and it stays at the row number 0 and column number the third column, so it's located here. However, I specify row span, so it will span 2 rows from first row to the second row. So that's why we get this figure. Similarly, you can modify by yourself with a command like this to get the figure like as you can see in this picture. And we can also use another command which is mpl dot grid specification and dot grid spec again. So in here I can make a big figure in the lower left corner, and the two AX1 and 2 AX2, which is smaller figure in the two sides, and in the right and on the top, also smaller figure in the upper right figure. So usually where, for instance, we use this kind of figure when we have let's say scatter plot in the AX0, and then this scatter plot was plotted based on 2 variables. We can plot for instance, the density function of the first variables in the AX1 panel, and the density function of the second variables in the AX2 figure. So, and we can also, as you can see here, we have a large space which is specified here as 0.5. We can also plot it smaller if we reduce this value, and here is closer because I specify as 0.1. Again, you can modify and play around with this information. So for this specific command, there is detailed instruction in Matplotlib website. So parameters is there, so you can certainly search and study more for yourself. Okay, this is all for this tutorial. Please let me know if you have any questions, and please subscribe my YouTube channel too. Thank you very much.